Hi friends, like mesh analysis which we studied in the last class, nodal analysis or node voltage analysis is another method for analyzing electrical networks. In this method, we will be utilizing Kirchhoff's current law, that is KCL, and Ohm's law. Now we will see the steps for analyzing a circuit using nodal analysis, and we'll try to do some examples using nodal analysis. For understanding the steps for analyzing a circuit using nodal analysis, we will go through one example. In this example, which is shown in figure 1, we are asked to find the value of V1, the voltage at this node, V2, which is the voltage at this node. We are also asked to find the power input output of the current and voltage sources. Identify the principal nodes. What is principal nodes? Principal nodes are where 3 or more branches are meeting. See here 3 branches are, one is this branch, one is this branch, and this branch are meeting. Here another 3 branches are meeting. Here also 3 branches are meeting, and here also 3 branches are meeting. So these are the principal nodes. Let us mark it as this one, this one, this one, and this one. Then the next step is, from these principal nodes, choose a node as a reference node and mark it as ground. See, we will take this as a reference node and we will mark it as ground. Next, let this reference node is V0. Then we will mark the other nodes as V1, V2, V3, etc. Next, from each node, we have to mark the current flowing through these elements connected to that node. So while marking the direction of current, we can do it in any way, towards or away from the branch. We will follow this way. Suppose 3 resistors are coming to this node, we will mark the currents are going away from the node. While in the case of this node, see, as this is an active branch and the current is in this way, so there is no doubt that the direction of current will be in this way. While in these resistive branches or passive branches, we will mark the current is going away from the node. Similarly, here also in this branch, we will mark as this is positive, current is going towards the node, and as this is passive branches, we will mark current is going away from the node. Suppose the current direction is in the opposite direction, the direction of this current also will be downwards. Similarly, if this voltage source is in the opposite direction, the direction of this arrow also will be in the opposite direction. Next step is, we have to write nodal equations for these nodes by applying Kirchhoff's current law and Ohm's law. We will take nodes one by one. At node V1, as per Kirchhoff's current law, incoming currents is equal to outgoing currents. See, in this node, this is a current source, so the direction will be in this way, and these two are resistive nodes. As we have said earlier, we will mark current is going away from the nodes. As per Kirchhoff's current law, incoming currents is equal to outgoing currents. That is, here incoming current is I1, which is equal to, let this current is I2 and then let this is I3. I1 is equal to I2 plus I3, or it can be written as I2 plus I3 is equal to I1. Here we are given I1 is equal to 1 ampere. Then as far as this branch and this branch are concerned, by Ohm's law, I is equal to V by R. That is, I2 is equal to V1 minus V3, V1 minus V3 divided by the resistance. That is, V1 minus V3 divided by 5. It is given that here it is 5 volt, which is the same here, and V3 is 5 volt. So this is equal to V1 minus 5 divided by 5. And here this I3 is equal to the difference of these two voltages divided by the resistances. I3 is equal to V1 minus V2 divided by the resistance is 5 ohm. Earlier we have seen that I2 plus I3 is equal to I1. This is equation 1. Substituting these values of I1, I2 and I3 in this equation, we can write as I2 we got as V1 minus 5 by 5 plus I3 is V1 minus V2 by 5 is equal to I1 is this 1 ampere. Multiplying by 5, V1 minus 5 plus V1 minus V2 is equal to 5. Expanding and simplifying this one, we will get 2V1 minus V2 is equal to 10. Let this is equation number 2. Then at node V2, applying Kirchhoff's current law, currents coming towards this node V2 is equal to currents going away from the nodes. So I3 plus I4 plus I5 is equal to currents coming towards the node is 0. Let it be equation 3. Then by Ohm's law, I is equal to V by R. That is I3 is equal to difference between V2 and V1. V2 minus V1 divided by the resistance is 5 ohm. I4 is equal to V2 minus this reference node where V is equal to 0. I4 is equal to V2 minus this reference node voltage, which is 0 divided by the resistance 2. That is V2 by 2. And I5 is equal to difference between these two voltages divided by resistance. V2 minus V3 divided by 4. V3 is 5 volt. So this is equal to V2 minus 5 divided by 4. Equation 3 can be written as I3 is V2 minus V1 by 5 plus I4 is V2 by 2 plus I5 is equal to V2 minus 5 by 4, which is equal to 0. By finding the LCM and expanding and then simplifying, LCM is 20. So dividing 20 by 5, 4 V2 minus V1 plus 10 V2 plus 5 into V2 minus 5 is equal to 0 divided by that LCM 20. And this LCM is brought to right hand side, it becomes 0. Then expanding and simplifying, we will get minus 4 V1 plus 19 V2 is equal to 25. Let this is equation 4. Solving equations 2 and 4, we will get V1 is equal to 6.325 volt and V2 is equal to 2.65 volt. Next we have to find the power output of this current source. Current source power output is equal to, we know that P is equal to V into I. Therefore, P is equal to this current and voltage V1. 1 ampere into V1, which is equal to V1, we know that 6.325 volt. 1 into 6.325, which is equal to 6.325 watts. This 5 volt is connected to these two voltage sources via this 5 ohm and 2 ohm. So for understanding, it can be redrawn as, so current flowing through 5 ohm is equal to I is equal to V by R, that is this 5 minus 6 point. Here also I is equal to V by R. Current through 5 ohm is equal to I is equal to V by R 5 minus 6.325 divided by 5, which is equal to minus 0.265 ampere. Current through 2 ohm is equal to 5 minus 2.65 divided by 2 ohm, which is equal to 1.175 ampere. Therefore, total is the sum of current through 5 ohm and current through 2 ohm, which comes as 0.91 ampere. Therefore, power out of 5 voltage source is equal to V into I, that is 5 into 0.91, which is equal to 4.55 watts. In this example, for the circuit shown in figure 2, we are asked to find the nodal voltages and current through this 2 ohm resistances. See here, this voltage source, which includes 12 volt and 6 ohm resistance, can be converted to a current source like this. Now, while converting, the resistance of this voltage source and current source will remain the same, while the current coming here is equal to 12 volt divided by that resistance 6 ohm. that is 2 ampere. So after converting this voltage source, we have converted to a current source. Here these two resistances are in parallel, which can be written as a single resistance, and the circuit can again be written as like this, because this 10 ohm and 6 ohm while in parallel becomes product of these resistances divided by sum of these resistances, that is 10 into 6 divided by 10 plus 6, which gives 3.75 ohm. Now we will find the voltages and current through this 2 ohm using nodal analysis. For applying nodal analysis, first of all we have to find the principal nodes. Principal nodes means where 3 or more branches are meeting. See here 1, 2, 3, 4 branches are meeting, while here 1, 2 and 3. These 3 are meeting. Here also 3 branches are meeting. We will mark it. This principal node, we will mark it as somewhere here, and we will take it as a reference node V0. Now we will ground it. So this is 0 volt. Here it is the next principal node, which we will mark it as V1, and here we will mark V2. Next thing we have to do is, from each node we have to mark the current flowing through the elements connected to that node. See here, this is a current source, so current flow will be like this. So let this is I1, which is equal to 7 ampere. In this resistive branch, let current is flowing away from this node, and let the current is I2. In this branch, let I3 is flowing in this direction. At node V2, this 2 ampere is coming in this direction. Here this is a resistive node, so we will mark current is going away from this, and we have marked this one as I3. In this resistive node, let current I4 is flowing away from the node. Let this current is I5, which is equal to 2 ampere. Then at this node 1, applying Kirchhoff's current law by Kirchhoff's current law at node 1. What Kirchhoff's current law is saying, sum of currents arriving at a node is equal to sum of currents leaving from that node. I1 is the current arriving, while I2 and I3 are leaving. So we can write I1 is equal to I2 plus I3. It is given that I1 is equal to this 7 ampere. I1 is equal to 7 ampere. Then by Ohm's law, I is equal to V by R. It is I2 is equal to, what is the voltage difference? V1 minus V0. That is 0 volt. V1 minus 0 divided by the resistance is 5 ohm, which can be written as V1 by 5. While here I3 is equal to, by Ohm's law, V by R, that is difference in voltages V1 minus V2 divided by this 2 ohm resistance. This equation becomes, equation 1 becomes I1, that is 7 ampere, is equal to I2, which is V1 by 5 plus I3, which is equal to V1 minus V2 by 2. Simplifying this equation, we will get 7 V1 minus 5 V2 is equal to 70. Let it be equation 2. Then by KCL at node 2, here these two currents are leaving, while I5 is arriving at that junction. So I3 plus I4 is equal to I5. I3 plus I4 is equal to I5. Let it be equation 3. But I5, we know that I5 is equal to this 2 ampere. Then as per Ohm's law, I3 is equal to V2 minus V1 by resistance. V2 minus V1 divided by the resistance 2, and I4 is equal to this V2 minus V0, that is 0 volt divided by 3.75. V2 minus 0 divided by 3.75. Substituting these values of I3, I4 and I5 in equation 3 becomes I3, that is V2 minus V1 by 2, V1 by 2 plus I4, which is V2 divided by 3.75 is equal to I5, which is 2 ampere. Simplifying this one, we will get minus 3.75 V1 plus 5.75 V2 is equal to 15. Let this is equation 4. Now solving equations 2 and 4, we will get V1 is equal to 22.2 volt and V2 is equal to 17.1 volt. Next we are asked to find current through 2 ohm resistance. See here, this is V1, this is V2. The current through 2 ohm we have to find. I is equal to V by R. Here the voltage is V1 minus V2 divided by 2 ohm, that is equal to 22.2 minus 17.1 divided by 2, which is equal to 2.55 ampere. In example 3, we are asked to find voltages VA, VB, VC and VD using nodal analysis. While using nodal analysis, first we have to mark the principal nodes, that is where 3 or more branches are meeting. One is coming here, then one is coming here, another here and another one here. Next we have to mark a reference node. Let this is the reference node where V0 is at ground potential and 0 volt. Then let the voltage at this node is V1 and here V2, while here it is V3. Next we have to mark the currents from each nodes. At this node, let this is current I1, this is current I2 and this is current I3. While in this branch, let this is current I2, this is current I4 and as this is a current source, current is coming in this direction. We will mark it in this direction and mark it as I6. In this node, let this is I3, this is current I4 going away from the node and this is current I5. Now applying Kirchhoff's current law at node V1. At node V1 by Kirchhoff's current law, the 3 currents are going away from this node. So I1 plus I2 plus I3 is equal to 0 as no currents are coming towards the node. Let this is equation number 1. By Ohm's law, I1 is equal to V1 minus V0 divided by 10. I1 is equal to V1 minus V0, which is 0, divided by resistance 10, which is equal to V1 by 10. I2 is equal to V1 minus V2 divided by resistance 5 ohm. And I3 is equal to V1 minus V3 divided by this 20 ohm. V1 minus V3 divided by 20 ohm. That is I is equal to V by R. Substituting these values in equation 1, I1 is V1 by 10 plus I2 is V1 minus V2 by 5 plus I3 is V1 minus V3 by 20, which is equal to 0. Simplifying this equation, we will get 7V1 minus 4V2 minus V3 is equal to 0. Let this is equation number 2. Then at node V2 by KCL, Kirchhoff's current law, I6 is coming towards the node while I2 and I4 are going away from the node. So I6 is equal to I2 plus I4, or it can be written as I2 plus I4 is equal to I6. Let it be equation number 3. It is given that I6 is equal to 10 ampere. I6 is equal to 10 ampere. As per Ohm's law, I2 is equal to voltage by resistance. Here V2 minus V1 divided by this resistance 5 ohm. V2 minus V1 divided by 5 and I4 is equal to V2 minus V3 divided by this resistance. V2 minus V3 divided by 10 ohm. Substituting these values of currents in equation number 3, equation number 3 becomes I2, V2 minus V1 by 5 plus I4, which is V2 minus V3 by 10. V2 minus V3 by 10 is equal to I6, which is 10 ampere. Simplifying this equation, we will get minus 2V1 plus 3V2 minus V3 is equal to 100. Let this is equation number 4. Then at node V3, applying Kirchhoff's current law, I3, I4 and I5 are leaving away from this node. So sum of these currents, I3 plus I4 plus I5 is equal to 0 as no currents are coming towards the node. Let this is equation 5. By Ohm's law, I3 is equal to V3 minus V1 by this resistance 20 ohm. I4 is equal to V3 minus V2 by 10 ohm. V3 minus V2 by 10 ohm. I5 is equal to V3 minus V0, which is 0, divided by 5 ohm. V3 minus 0 divided by 5. Substituting the values of I3, I4 and I5 in equation number 5, I3 is V3 minus V1 by 20 plus I4 V3 minus V2 by 10 plus I5 V3 by 5 is equal to 0, which can be written as minus V1 minus 2 V2 plus 7 V3 is equal to 0. Let this is equation number 6. Solving equations 2, 4 and 6, we will get V1 is equal to 45.45 volt, V2 is equal to 72.72 volt and V3 is equal to 27.27 volt. We are asked to find the value of VA, VB, VC and VD. Here this is V1, V2 and this is V3, while this is at a ground potential V0. VA is equal to V3 minus 0, that is equal to this 27.27 minus 0, which is 27.27 volt. Then VB is equal to V1 minus 0 volt, which is equal to V1 is 45.45 volt minus 0, which is 45.45 volt. Then VC is equal to difference between this V1 and V3, V1 minus V3, which is equal to, what is V1? V1 is 45.45 minus V3 is 27.27, which is equal to 18.18 volt. Then VD is equal to difference between these two voltages, V2 minus V3, that is 72.72 minus 27.27, which is equal to 45.45 volt. Example 4. Here we are asked to find voltage VA using nodal analysis. See, these two resistances are in parallel, so it can be combined and the circuit can be redrawn as like this. When this 2K and 2K are in parallel, it becomes 2 into 2 divided by 2 plus 2, which is equal to 1 kilo. Next we have to identify the principal nodes. Let this is node 1, this is node 2 and this is node 3. Principal node means where 3 or more branches are meeting. Next we have to mark one principal node as a reference node. Let this is that reference node and here V0 is equal to 0 volt. Let the voltage at this node is V1 and at this node is V2. Now we will mark the currents from each node. Let this is I1, this is I2 and this is I3. This branch and this branch are resistive nodes, so we have marked it as currents flowing away from this node. This is a branch containing current source and already the direction is given as going towards bottom like this. At V2, this is the current in this branch is I3 and let us assume it is going away from this node. In this branch, as it is a resistive node, let us assume a current I5 is going away from the node. In this branch which is containing a current source, the direction is in this way, let it be I4. By Kirchhoff's current law, KCL, at node 1, I1, I2 and I3 are going away from the node, so we can write I1 plus I2 plus I3 is equal to 0 as no currents are coming towards the node. Let this is equation number 1. We know that current I2 is 3 milliampere. I2 is equal to 3 milliampere. Then current I1 is equal to V1 minus V0 divided by 3K. V1 minus V0 by 3K. V0 means 0, that is V1 divided by 3K means 3 into 10 raised to 3. Then I3 is equal to difference between V1 and V2 divided by 2K. I3 is equal to V1 minus V2 divided by 2K, which is equal to V1 minus V2 divided by 2 into 10 raised to 3. Substituting the values of I1, I2, I3 in the equation number 1 becomes V1 by 3 into 10 raised to 3 plus this 3 milliampere. I2 is 3 milliampere, which is equal to 3 into 10 raised to minus 3 ampere, plus I3 is equal to V1 minus V2 divided by 2 into 10 raised to 3, which is equal to 0. Simplifying this equation, we will get 5V1 minus 3V2 is equal to minus 18. Let this is equation number 2. Applying Kirchhoff's current law at node V2, here also 3 currents are going away from the node, I3, I4 and I5. So I3 plus I4 plus I5 is equal to 0. Let it be equation 3. Here I4 is given as 1 milliampere, which is equal to 1 into 10 raised to minus 3 ampere. Then I3 is equal to V2 minus V1 divided by this resistance 2K. I3 is equal to V2 minus V1 by 2K, that is equal to V2 minus V1 divided by 2 into 10 raised to 3, and I5 is equal to V2 minus reference V0 0 divided by 1K. V2 minus 0 divided by 1K, that is equal to V2 by 1 into 10 raised to 3. So equation 3 becomes I3. I3 is V2 minus V1 by 2 into 10 raised to 3 plus I4. I4 is 1 into 10 raised to minus 3 plus I5. I5 is V2 by 1 into 10 raised to 3. This is equal to 0. While simplifying this equation, it becomes minus V1 plus 3 V2 is equal to minus 2. Let this is equation number 4. Solving equations 2 and 4, we will get V1 is equal to minus 5 volt, V2 is equal to minus 2.33 volt. We are asked to find the voltage VA, which is across that 3 kilo ohm resistance. VA is equal to the voltage difference between this node and reference node, V1 minus 0, that is equal to 5 volt. If you found any difficulty in understanding any terms used in this class, you can go through my previous classes, the links of which are given below. Thanks for watching. Please like it, share it and subscribe it by pressing that bell button so that you will be receiving all the notifications of my future videos also. See you next time. Bye.